All right, in this lesson, we're going to look at selections, which are known as combinations, which are different from arrangements because now order is important. And I'll talk you through what I mean. We'll look at this example here. 4 flavors of ice cream, vanilla, chocolate, strawberry, and caramel, are available at the school. How many different double scoop selections are possible if 2 different flavors must be used? Okay, so we can just write them out. We could go vanilla, chocolate, vanilla, strawberry, vanilla, caramel. We could go chocolate, vanilla, chocolate, strawberry, chocolate, caramel. We could go strawberry, vanilla, strawberry, chocolate, strawberry, caramel. Or we could go, oh, yeah, it was chocolate caramel, wasn't it? Yep. Caramel, vanilla, caramel, chocolate, and caramel, strawberry. Now I didn't go double up because it said 2 different flavors, not 2 of the same. All right, so we can see here that there are, 12 combinations, which we could have worked out using yesterday's work on arrangements. We could have gone not 4 in the first one. No, 4 by 3, because there's only 2 slots and we can't have double ups, so we're going to use 1 less. All right, so 4 by 3 equals 12. Good, arrangements work. However, this is about selections, not arrangements. So we can see here that vanilla chocolate is the same as chocolate vanilla. Effectively, you've got the 2 same flavors. So we can cross out one of them, right? Not both of them. So this was vanilla, chocolate, chocolate, vanilla. So we'll cross out double ups. So there's a double up. What else have we got? There's a double up there. And you can see there's a double up there. And 1 there. All right, so we've got 4 missing. Now I've got 1, 2, 3, 4, 5, 6, 7, 8. Is that all? Oh no, there's another double up there because chocolate caramel. And last double up is here with VC and CV. So I've got 1, 2, 3, 4, 5, 6 left. So there are 6 possible combinations here of flavors that I could choose given the question. All right, so now what's the maths behind it and how do we calculate it? So we're going to have to look at arrangements and manipulating them. So we know that this plays part of it. Okay, so I've got 4 by 3, and I'm going to use the factorial notation instead of the shorthand. So it should be 4 factorial over 4 minus 2 factorial, which we knew was 4 by 3 by 2 by 1 all over 2 by 1. All right, so we know that those parts are going to cancel out. Okay, but the answer to this was going to be 12, and I need 6. All right, so the obvious step now is to chuck another 2 under here, like that. All right, so that now I'm going to divide the end result by 2 also. However, it's not that simple. Right, it's a bit of a hidden arrangement. It becomes easier to see the bigger the set we use. So I'm just going to tell you what the formula is. Underneath the denominator here is also going to be that number again. All right, so whatever that number is, we write it factorial again. So the formula looks like this. It's n factorial divided by r factorial over times by n minus r factorial. Now what that looks like with bigger sets, if we do the example again, we would have this here. We would have 4 factorial all over, r is how many choices we have, 2 factorial. This is 4 minus 2, which is 2 factorial. And now I have 12, oops, sorry, not 12, it's 4 by 3 by 2 by 1. So it's 24 over 2 factorial is 2, 2 factorial is 2, so that's 4. 24 divided by 4 is 6. So we can see it worked out. All right, now this is the formula we use for combinations. All right, on your calculator, it looks like this, NCR. C stands for combinations. This is the number the pool you have to draw from. This is the number of spots you have. All right. So on your calculator, you would type in NCR, or you could hit the button. Then for the example for this one would be 4, 2, and it would tell you the answer was 6. All right, so this is a calculator entry line here. Now, the way we write it in our books is we would go 4, choose 2, and luckily C also stands for choose because we are choosing a number of selections. So 4C2 we can write as 6. And the calculations we would show would look like this: 4 factorial over 2 factorial, 2 factorial equals 6. All right, so you can see there that combinations is slightly different from permutations because the order was important. We didn't want any of the double ups. We only wanted one of the same of each one. All right, so let's have a look at a few examples so we can practice. So we've got a team of 3 boys and 3 girls to be chosen from a group of 8 boys and 5 girls. How many different teams are possible? So this has got multiple parts. Let's break it down. We want 3 boys and 3 girls. 3 boys can be chosen from 8. 3 girls can be chosen from 5. So I have, using my notation, I have 8 choose 3 for the boys, and I have 5 choose 3 for the girls. So now I just need to calculate what these are. So this is 8 factorial over 3 factorial, 5 minus 3 factorial. And for the girls, it's going to be 5 factorial over, 3 factorial, 5 minus 3 factorial. All right, so I can calculate those out and I end up with some combinations there. So for the boys, it was 56. For the girls, it was 10. Now, because I'm choosing a team that has a combination of the boys and the girls, what I need to do is to multiply those two numbers together to get my total number of teams that I could possibly have using both the boys and the girls. Okay, so that's like a combination from a couple of lessons ago where we're looking at the multiplication rule. Okay, so this is really important, this part here, writing it like this. The calculator can do the calculating for us, but the important part here is that we can identify the group size and how many we are choosing. Group size and how many we are choosing, and then convert that into the formula. All right, so another example would look like this, about a party. Nick is making an invitation list for his party and has 7 friends to choose from. If he may choose to invite any number of friends from 1 to all 7, how many possible party lists does he have? Assume he will invite at least 1 person. That's what it said. So we can't choose none. All right, so the number of possible parties he has could look like this. We could have 7 choose 1, 7 choose 2, 7, I'm getting bigger here. 7 choose 3, 7 choose 4, 7 choose 5, 7 choose 6, 7 choose 7, and then we just add them all together because they're all different parties. We're not multiplying them because we're not looking to make a team of parties. We're looking to add them because they are different parties. We could have this party or this party or this party or this and so on. Okay, so that's why it's not it's multiplied. All right, so to answer this question, once we know that, I'm going to show you this neat little formula, and I could explain how it works, but for now we just need to know that this works. So if I have any group size, choose 0 plus any group, the same group size, choose 1 plus 2 plus 3 plus 4, all the way to the end, it just equals 2 to the power of whatever the group size was. All right, now this works because I'm choosing to look at this in a different way. I'm choosing to instead say to myself, person 1, I could choose or not. So there are 2 options there. Person 2, I could choose or not. So there are another 2 options there. And because it goes down to 7, there are 2 to the power of 7 options, which is what this little formula here says. All right, so there are 2 to the power of 7 options if I choose everyone, but notice this starts at 0 and we've started at 1. So I need to subtract out that result. And because there's only one way to choose no one comes, I just subtract 1. So the final answer is 2 to the power of 7, take away 1, which is 127 different ways or different parties that this person could have, given that he can invite anyone from 1 through to 7. Okay? So then to recap, this lesson is about combinations, which are different from arrangements because now double ups are out the window and we're interested only in unique results. And this is the formula we use to calculate it. And this is the entry line we would type on our calculator. NCR bracket 4, 2, group number available, group size.